to introduce a gentleman that is going to introduce a speaker. And I'm introducing the introducer here because Robert Chen is a scientist of international renown. He's with CEASON, which is an institute within the Earth Institute in Columbia. He's the director of that institute. And Bob Chen has many credits to his resume, but one of them that is, I think, very profound is that I think it was 1981, when he was a student at MIT, he hand drew the first sea level rise map for his professor. So with his great pleasure that I introduce Dr. Robert Chen, who will introduce our next speaker.
Thanks, Bill. I was going to partly tell that story. Yeah, actually, well, Bill didn't say what I thought he was going to say, which is I'm related to him. He's my brother-in-law. But I did come to this issue. It's kind of full circle for me because my first published scientific paper was on the impact of a potential deglaciation of the West Antarctic ice sheet on the U.S. coastline. So all these maps are, unfortunately, back then it was a scientific scenario, and it was published in 1980, actually. And you know, unfortunately now it's a real threat. And so things have changed a lot, but unfortunately not necessarily in a positive direction. But I think this kind of group is really interesting to talk to because of the much greater awareness of this type of issue and the potential for really addressing it in a way that will hopefully ameliorate the risk. So it is my pleasure to introduce this session, which is about the triple threat about rising sea levels, extreme storms, and aging infrastructure. And I'm really pleased to have the opportunity to introduce the two speakers who are really people who have been working in this area from different directions. The first speaker, Cynthia Rosenzweig, is actually someone I've known for 20-odd years. Yeah. And is a colleague of mine at the Earth Institute. She's at the NASA Goddard Institute for Space Studies, but is also affiliated with the Earth Institute and is a professor at Barnard College. My center worked with her more than 15 years ago on an early study of the potential of climate change on New York City, the Metropolitan East Coast Assessment. And since then, she's been involved with the New York Panel on Climate Change, the Intergovernmental Panel on Climate Change, and a lot of other activities, a network of cities looking at climate change, a big study of the impacts of climate on agriculture, and she'll, I'm sure, give you a real update on the activities, looking at it from an urban perspective. So, Cynthia?
And thank you to Bill Golden for inviting me. I was also at the first of these meetings that was held at the Kennedy Library, and so I'm very happy to participate again and share recent work, some of the science at the different telescoping scales, from global scales to national scales down to local scales. The local I'm going to be talking about is right here in the New York metropolitan region. But before I start, I have to hold up a piece of paper. I still believe in paper in some cases, because this is the New York Times this morning with the headline about the National Climate Assessment that was just released yesterday that Kristen was talking about. And it's so important that this assessment of record is now has now been put forward nationally so that it can serve as an integrating function across the whole country as each region delves into the individual and specific challenges that they're facing. So I'm going to turn to covering briefly some of the global sea level rise projections and coastal zone findings, primarily from the recently released Intergovernmental Panel on Climate Change, Fifth Assessment Report. So that's the global scale. then a little bit on what the national assessment brought forward yesterday on the coastal issues, which is the topic of the day here at NICHI, and looking at some of the regional work that we're doing. Then focusing straight down to here in the New York metropolitan region. And then considering what do we really mean by resilience and adaptation, and how can we really work together to promulgate a way forward that is going to be resilient to the climate shocks that are being projected, but that are also projected to change in the coming decades. So we have to be doubly resilient, not just to the ones that we understand right now, to the climate risks and hazards that we understand right now, but we have to understand that our climate system is evolving through time. So we have to be even smarter to prepare for the changing changes. So let's turn right to the IPCC. What did they say? What did our global colleagues, and I worked with this group for many years, what were they bringing forward about sea level rise? And here's the scoop from the global scientists. First, and it's the top graph, is what's happening with the Arctic summer sea ice extent. And over what we see is that over the last 2 decades, the Greenland and Antarctic ice sheet, and Bob, you wrote one of the first papers on this, have been continuing to lose mass. Glaciers have continued to shrink almost everywhere worldwide. And the Arctic sea ice and Northern Hemisphere spring snow cover have continued to decrease in extent. So this warming world is having effects on the cryosphere of our entire planet. The middle graph is showing the change in the global average upper ocean heat content. What else do warmer global temperatures do besides melting ice and snow? It warms ocean temperatures. So the IPCC has found that it is virtually certain that the upper ocean has warmed from the 70s to today, and they say very likely they're very careful. We scientists are extremely careful when we make statements over what time period and over what geographical extent we can specify the changes. And then we give confidence interval, we give a confidence statement. So the IPCC scientists felt that it's likely that the ocean has been warming much longer than that since the 1870s. But it's virtually certain, and that's what's shown on the graph, is the warming in the recent decades. The bottom graph is showing the sea level rise itself. And the bottom graph is from 1900. And here, but they do compare the rate that we're experiencing now to earlier centuries. So the third finding is that the rate of sea level rise since the mid-19th century has been larger than the mean rate during the previous 2 millennia. So these changes that we're seeing are very special to this time, and they are larger than what we've seen over large time periods. And finally, from the past 100 years, globally, mean sea level has risen by about 8 inches when you average all around the world. So that's the scoop from the Global International Panel on Climate Change.